Hello everyone. Welcome back to my channel again. Have you ever looked up at the stars and wondered, where did we all come from? How did this beautiful blue marble we call home even begin? It's a story that starts a long, long time ago, around 4.6 billion years in the past. It's an epic tale of cosmic dust, unimaginable heat, and relentless gravity. So, let's rewind the clock, all the way back to the very beginning, to witness the birth of our world. Our story begins not with a planet, but with a star, our very own sun. Newly born and glowing brightly, around this young star was a massive, swirling disk of gas and dust, kind of like a cosmic frisbee. This was the solar nebula, the raw material for everything in our solar system. Think of it as a giant construction site, filled with trillions upon trillions of tiny particles of rock, ice, and metal, all leftovers from the sun's formation. For millions of years, this disk just spun, a chaotic cloud of potential. But then, a quiet force began to work its magic: gravity. At first, it was a gentle pull. Tiny dust grains started to stick together, a bit like how dust bunnies form under your bed. These little clumps, no bigger than pebbles, slowly grew. As they got bigger, their gravitational pull increased, allowing them to attract even more material. It was a cosmic snowball effect. Pebbles became rocks, rocks became boulders, and boulders smashed together to form what scientists call planetesimal small, early-stage planets, some hundreds of miles across. The early solar system was a violent and chaotic place. It was like a cosmic demolition derby. These planetesimals were constantly colliding, crashing into each other with incredible force. Most of these collisions were destructive, shattering the bodies back into smaller pieces. But every now and then, a collision would be just right. Instead of shattering, the two bodies would merge, creating an even larger object. Over millions of years, through this relentless process of accretion, the biggest players in this cosmic game started to dominate, clearing out their orbital paths. One of these winners was a growing protoplanet that would eventually become our home, Earth. As the young Earth grew, each collision added more mass and, crucially, more energy. Every impact from a massive asteroid or planetesimal was like a giant explosion, releasing an incredible amount of heat. The planet was so hot that its entire surface was a molten ocean of lava. Forget water, forget land, imagine a glowing, red-hot sphere of liquid rock, constantly churning and bubbling under a sky choked with hot gases. Temperatures were extreme, reaching thousands of degrees. This was the Hadean Eon, a name fittingly derived from Hades, the underworld. Our planet was a literal hellscape. During this molten phase, something incredible happened, a process called planetary differentiation. The heavier elements like iron and nickel were pulled by gravity toward the center of the planet. They sank through the liquid rock, accumulating to form Earth's dense metallic core. The lighter materials, the silicate rocks, floated to the top, eventually cooling to form the mantle and the crust. This sorting process is why Earth has its layered structure today: a solid inner core, a liquid outer core, a thick mantle, and a thin outer crust. It's like a perfectly layered cosmic cake. And it all happened because our planet was once a giant ball of fire. But the chaos wasn't over. Around this time, probably within the first 100 million years of Earth's existence, the most significant event in our planet's history occurred. A Mars-sized protoplanet, which scientists have named Theia, was on a collision course with the young Earth. The impact was cataclysmic, an explosion of energy that dwarfs anything we can imagine. The collision was so powerful that it tilted Earth on its axis, giving us our seasons, and blasted a massive amount of molten rock and debris into orbit around our planet. This ring of debris didn't just float away. Once again, gravity took over. The particles began to clump together, accreting just as Earth had done, but on a smaller scale. Over a remarkably short period of time, perhaps just a few thousand years, this material coalesced to form a new celestial body. This body was our constant companion, the ruler of our night sky. The moon, the giant's impact hypothesis as it's called, explains why the moon is so large compared to Earth and why its composition is so similar to Earth's mantle. Our moon is, in a very real sense, a child of the Earth, born from a violent and spectacular collision. After the moon's formation, Earth began a long, slow process of cooling. The surface, no longer constantly bombarded by giant impacts, started to solidify. A primitive crust began to form, like a thin skin on the surface of the molten rock. But this early crust was fragile and unstable. Volcanic activity was rampant. Volcanoes spewed lava and, importantly, gases into the atmosphere. This process, called outgassing, released huge amounts of water vapor, carbon dioxide, nitrogen, and other compounds that had been trapped inside the planet. This created Earth's first true atmosphere. But it was nothing like the air we breathe today. It was a thick, toxic cocktail of gases with virtually no oxygen. And as the planet continued to cool, a critical tipping point was reached. The water vapor in the atmosphere, which had been building up for millions of years, began to condense. It started to rain. And it didn't just rain for a day or a week. It rained for centuries, a relentless, planet-wide deluge. This great rain filled the low-lying basins and craters on the newly formed crust, giving birth to the first oceans. So, here we were, a rocky planet with a metallic core, a solid crust, a primitive atmosphere, and vast global oceans. It was still a harsh and alien world, but the stage was set. All the necessary ingredients were in place, from a chaotic disk of dust and gas. Through fiery collisions and molten oceans, our planet had finally formed. It had taken hundreds of millions of years of cosmic violence and planetary transformation. But the early Earth was finally ready for the next, perhaps even more incredible chapter in its story, the origin of life. And that is the incredible, fiery, and violent story of how our planet came to be. It is a reminder that we are standing on a world forged in the crucible of the cosmos. Every rock, every ocean, every breath of air is a legacy of this 4.6 billion year journey. Thank you so much for joining me on this trip back in time. If you found this cosmic story as fascinating as I do, please hit that like button and subscribe for more adventures through space and time. See you in the next one.